Okay, I think we'll slowly get started. Timer's ticking. Welcome to my talk. Thanks for coming. I'm really happy to be here, very excited. And today we're going to talk a little bit about building an agentic platform with Kotlin. Well, let me just introduce myself quickly. My name is Patrick Whelan. You can call me Pat. I've been a software engineer now for over 20 years. I've been in the back end, I've been in the front end. I've been on mobile, which is where I met Kotlin and fell in love. And I've been spending the last 2 years helping the Deutsche Telekom build one of the biggest LLM-powered chatbots in Europe. At least that's what we like to say. But okay, let me start off with probably one of our biggest learnings over the last 2 years. And I'd like to bring this up now because I think it provides good context for the rest of my talk. So I'm sorry to say, but you're never going to deploy a perfect LLM application into production. Doesn't matter how much testing you do, once you deploy it, it will simply behave differently, and therefore it is vital to continuously evaluate and improve your LLM application. Now, the AI system that enables you to execute this feedback loop, as we call it, the quickest, that is the best AI system. Okay, so let that sink in for a bit, and we'll touch again on this at the end of the presentation. But okay, I said we're one of the biggest LLM-powered chatbots in Europe, so let's back this up with a few numbers. So we have roughly around 500,000 conversations a month. This translates to like 2 to 3 million LLM calls. Although we try and keep the number of LLM calls per turn down, because obviously that saves a lot of cost. Now, when we're good, we have an acceptable answer rate between 80 and 93%, and we've launched in over 3 countries, and we want to triple that within a year. We also have 20 AI agents deployed in production. And so it's a lot of trendy now with different AI agents. We've been doing this, I think, for over a year now. And when I say AI, just to clarify, I mean generative AI and LLM models and so on and so forth. But maybe just a quick show of hands, because I've been talking to people before. Does anyone know what an AI agent is? Or doesn't know what an AI agent is? Okay, yeah. So it's a pretty common, I think, topic at the moment. But okay, let's take a look at our system. So as you can see here on the left-hand side, we have a bunch of different touch points. Now these can be from different countries, it can be from different channels, like on web, on mobile, and they all communicate with our central LLM chatbot, our multi-agent platform written in Kotlin. That's why I'm here today. And as you can see, on the right-hand side, we have some services. We have the the anonymization service, because all the data we feed to the LLM is anonymized, and that's very important for us at the Deutsche Telekom. We have some memory, some cache, where we cache some data, but we don't really currently persist much data. And for this, we use Redis. Then we have our search service. This is quite important because it's where our vector DB is hosted. And currently we're using Quadrant, which is also something I could recommend. And this vector database gets filled with these so-called RAG pipelines that are just these tasks that are run on different events, pulls data from different sources, and feeds the vector database with that data. Then here on the bottom, we have the customer APIs. So we let the LLM interact with your customer data so we can generate a proper response. And then on the right from that, we have here our LLM model. We're using an OpenAI model running on Azure. And here, I like to highlight this guardrails. See that? So we haven't quite fully implemented this, but I really want to bring this up because it's quite an interesting trend that has emerged over the last few months. Basically, it's kind of like a proxy in front of your LLM that implements the OpenAI API and allows you to build features on top of it, for example, guardrails. Now, the cool thing about it is, because it implements this API, you can slot this into like any AI system you may be wanting to build or buy. So definitely something to consider if you're creating your own, maybe AI system. Okay, so let's take a look at our agents. Now, what we've done here is we've broken down our LLM bot into multiple agents, each agent focusing on a specific business domain and deployed as a separate microservice. Now, if you don't like microservices, that's fine, but we kind of recommend it because it allows you to update or roll back a single agent without disrupting the whole ecosystem. And with LLMs, it's always a little bit unpredictable, so this feature is definitely something I think we'd recommend. But okay, so what happens? So we have quite a simple construct. We have a supervisor agent. The supervisor agent gets the question from the customer, like, what was my bill last month? Now, the supervisor agent classifies this, in this case as a billing intent, and routes the conversation to the billing agent. Now, the billing agent has three ways it can respond. It can either say, or give us a perfect answer, which is great, but it can also say, well, I can't really answer that. And that's fine. The classifier isn't perfect, and the classifier will just simply route that conversation to another agent. The third option the agent has is it can say, I can't answer this question, but I know who can. And so it could say maybe a handover to the contract agent, in which case the supervisor would just simply take that and hand it over to the contract agent. So yeah, it's quite a simple construct, but the important thing is that the customer doesn't know what agent is talking to. For the customer, it still has a single contact point, which is the LLM bot. But yeah, I always get a lot of questions on this like agent collaboration and networking, so we'll do a question session at the end, but we'll also be touching a little bit on this within our demo. Okay, so let's go one level deeper. How do we code this, right? So I have here, I don't know if you can see that. Yeah, we have here one of our first agents. As you can see here, as traditional Java developers, we took a very traditional Java developer approach. We had a billing agent implementing an agent interface. We had like a prompt repository and a whole bunch of other classes we were injecting. And as you can see, there's quite a lot of boilerplate code here. And this was kind of like the problem. Once we started scaling this up to a lot of use cases and to a lot of teams, it really didn't quite work out. It was too rigid. But what really hurt us was the fact you couldn't prototype with this construct. You couldn't try things out. You couldn't just mess around and just prototype a solution. And the evidence for this was that we had our developers prototyping or creating their solutions outside of the framework in like a notebook LLM, and then having to transition this into our very rigid and complicated framework. So we knew we had to do something. So we did what any engineer would do. We created our own framework. Yay. So let me introduce you to Arc, an agentic AI framework written in Kotlin. The goal of Arc to take the same technology using prototyping and take that into production. And at the core of Arc, we have this Kotlin DSL, one of my favorite Kotlin features, that is designed specifically to help create AI agents concisely and quickly. This is all open source. We're also part of the Eclipse Foundation. And yeah, but enough of my sales pitch, my elevator talk. Let's maybe look at some code and how this actually works. Okay, so we're going to start off where you would start off any program in the main function. So I hope you can read this. It's fairly simple. We have an agents function. And within this agent function, we can use the agent DSL to specify one or more agents. We have to hook it up to a model, obviously, and there's different ways you can configure this. Usually you'll just configure it using environment variables or system properties. Here you can use the very common OpenAI key attribute. Just set your key and it will automatically discover it and create your model client appropriately. Once you've defined your agents, you can just say serve, and this will kick up a key to our application service that will host your applications. And then we have a dev mode here that will launch our chat UI so that you can communicate with your agent. But I don't really want to start like that because I like to combine my agents with my second favorite Kotlin language or Kotlin feature, and that is Kotlin scripting. So instead of this up here, I'm going to do this instead. So what I'm doing here now is I am pointing this hot reload agents to an agents folder. And I'm doing the same thing. I'm serving it. So again, this will create a key to our application service. And here, just note this for now, I'm passing it this bean, which is obviously a custom bean for today's presentation. Once you've got this up and running, we can now start taking a look at the agent DSL. So this is Bit. So I'm going to split this demo in like two parts. I'm going to give you like a little introduction into the DSL, the basics of the DSL. And then we're going to do a little demo where we look at a supervisor agent and see how that can be done. But okay, I hope it's fairly clear what we're doing here. We have an agent. We give it a name. There's other attributes you can give an agent like version or description and so on and so forth. Then we have here a model. And I think it's always important to define the model your agent was tested with, because otherwise it's very hard to understand like what the requirements of this model or this agent. In the past, we've had trouble deploying things in production and not knowing what kind of model to associate with the agent. So that's why we like to make it here explicit. Then we have the filter input and output. Now this allows us to transform or to validate the input and the output of the agent. So here we have, for example, an LLM-based filter, where we use an LLM to try and detect if our customer is trying to hack our bot, which unfortunately happens more often than one thinks. We also like to use a bit of the Kotlin magic here, where we're overloading this minus, which allows us to remove certain words from the output. Now, we have quite a lot of these, kind of like a little bit of hacks and tricks that we have, which is basically, once you've done prompting for like 500 hours, you start enjoying these hacks a lot more than having to try and prompt, which can take up to a few hours. The same thing with the output. We have here a hallucination detector, and here we're using code. So this is quite simple. We're using code to extract certain data types from our output, like emails, telephone numbers, URLs, and comparing that with the input we feed to the LLM. So this is a very cheap and easy way to detect these hallucinations. Then we come for tools. Tools, I think, is common knowledge now. LLMs can accept tools or functions that allows us to expand their functionality. More on that in a second. But now we come to the heart of the agent, where we have here our prompt. Now you can make multiple LLM calls throughout the agent, but the prompt is basically where we define the core instruction behavior of our agent. And as you can see here, we have kind of like a string builder concept going on, where we're using this plus sign here to allow us to build this prompt. Now this is where we've had a lot of change over the last year. When we started out, we had the prompts as static strings, and that just doesn't work. I mean, you just sometimes just want to tell the LLM what time it is, right? So it has to be dynamic. Then we moved it out into like these property files, these templating property files. But then you had to like maintain 2 code bases, and that was also kind of cumbersome. So that's why just injecting it here is, I think, our recommendation, even though you can do it maybe a little differently. But yeah, as you can probably tell from this function here, this actually gets executed on every single request. And this is vital for us because it allows us to customize the agent, not only for our customer, our channel, our country, or whatever, but it really gives a better experience to the user, and also saves us on creating an agent for each and every channel. Now, as you can tell, this doesn't just apply to the prompt. We also use this dynamicness to the filters, to the tools themselves, and to the model. So we can make it very NatCo specific what kind of tools you get, because not all NatCos support all tools. So a very powerful construct there. Now, another part of the DSL is its functions. And as you can see here, we're using the memory function. Memory function is great. LLMs don't yet have memory. So this allows us to simply retrieve some data that we stored earlier or later on. And we can take the username, and we can just add it here within our system. But we have a lot of functions. So if you want to make an LLM call, that's a function. You want to make a HTTP call, that's a function. We have basically a function for everything. But again, we want to allow you to be able to create your own functions with a little bit of ease. So let's just pop here into this custom function that we created here for this demo. And as you can see here, the magic behind this function is this DSL context. This DSL context allows us to grab this magical get function. And the magical get function allows us to access any beans that we've given to the agent in this agent's context. If you're running this in Spring Boot, we also have a Spring Boot starter, which is what we actually use in production. This will automatically give you access to any beans within your Spring Boot container as well. But yeah, it's a super simple construct, but allows us to take very complicated tasks and just simply design them as simple methods. Okay, how do I get back now? Where did you go? Okay, so that's basically the basics of what we can do here with our agent. And this is the tip of the iceberg, but I think it's maybe a good starter to get into it. Okay, so now let's go over to our demo. Okay, and supervisor. So as I promised, we're going to look at a supervisor agent, like what are the ways how we can create this, and also look at maybe some of the patterns that you can use to create kind of like agent collaboration, which is all, I think, a hot topic at the moment. But first of all, let's just take a look. So this is our chat interface we have, which allows you basically to chat to your LLM agent. This is a great progress. When we started out, we were using curl commands to talk to the LLM bot, which is very cumbersome, so we're very happy for this. But okay, we have a supervisor agent, so let's ask it a question. Let's ask what the weather is like in Berlin. Okay, so as you can see here, we have like two responses. The first response is more of a debug response. And it's telling me that it's calling the weather agent with the question, what is the weather like in Berlin? And it's giving the answer, which is 32 degrees, which is probably not correct. But yeah, so we can see that although we're talking to the supervisor agent, we're getting a response on a topic that the supervisor agent doesn't really have anything to do with. So let's make it a little harder. Let's say, please book me a hotel in Berlin, but only if the weather is good. Oh, no. Wait, did it work? No, it didn't. Try this again. I did say something about LLMs being quite unpredictable. Okay, I think that it worked this time, yes. So as you can see, the supervisor agent is calling two agents. It's calling the weather agent, asking what the weather is in Berlin, and it's calling the booking agent, asking the booking agent if it can book its hotels. And then it's coming to the conclusion that because the weather is good, it is actually going to now book the hotel. So not only is the supervisor agent coming or talking to other agents, it's collaborating those agents together to come up with its response. Okay, just maybe another touch here on the UI itself. So as you can see here on the right, we have here a lot of kind of like traces and events. And this gives you basically a very good indication about what your LLM is doing. Okay, but how do we create this? I'm gonna look here. So again, you can see the syntax you're all hopefully very familiar with. We have our supervisor agent, and here we have a very simple prompt. And down here at the prompt, we're basically listing all these different agents that it has access to. Now, I've done this here statically, but obviously we can make this dynamic. And then we have just simple prompting here. Now, obviously, if you want to take this in production, our prompts are probably like 3 times this size. But I was going to do a different demo, and I decided this is maybe more interesting, so I did this in like half an hour. Now, once we have here the supervisor agent, we have here this call agent function, right? So let's look behind that. So not only do we have a DSL to define agents, we also have a DSL to define functions. Here we have a simple call agent function. We're giving it a description, and we're defining 2 parameters. One, the name of the agent to call, and the second is the question to ask that agent. Now, this is kind of important because you don't want to ask the weather agent about booking hotels. So it needs to rephrase the input of the customer to then be able to talk to that agent. Then here we have like this emit a message, which is where we see kind of like these default debug statements. And you can put anything in here. The idea is that one single question from the customer can result in many responses from the server. This is particularly helpful if you have like long-running tasks and you want to give the feedback to the user that you're actually doing something. Here we're memorizing the last agent that was called. We're not actually using it in this demo, but this is a helpful key for the LLM supervisor to understand, okay, I was just with this agent. I'm not quite sure about this answer, so I'm going to go back to that agent maybe. Then, in order to actually call the agent, all you have to do is ask the agent. Now, this is a function call here, and all it's going to do now is going to call that agent with that question and return a reply. You have other options, though. So you have, for example, here the break to agent function, and this is pretty much what we have in production. So this means that we will hand over the conversation to the agent without having to integrate the response from the agent within our own response. And then we simply here return the reply. The cool thing about functions, or in general LLM functions, is all you have to do is return a string. You don't have to worry about modeling complex data models or DTOs. You just return a string. And we're going to see that if we look at maybe one of the other agents. So again, here's a super simple agent. I gave it a little bit of prompting saying you answer questions about weather. And here I'm just giving it a weather function. And as you can see here, I was faking it, which is why the weather was so good. But again, it's a great thing to just kind of like test and experiment with. Yeah, and that was it. One thing that, again, I think is cool about this kind of like construct we have, as soon as I make any changes here to any of the files, we have this hot reload. And so you can see here, we're now reloading that function. And this is kind of like a bit of a game changer for us because it allows us to prototype those solutions that I was talking about really quickly. Okay. So that's the demo part over already, unfortunately. Yes. We don't actually use the script files. I showed you where we're using Kotlin scripting language. We're not only using this Kotlin scripting language, we're also using the custom Kotlin scripting language. So hopefully the Kotlin guys will keep that around. But we don't use this in production. We have a transpiler, which basically does nothing but copy those strips into a class the body of a class. So any of you have a better solution or a better idea on how to handle this, please contact me, because we don't want to take these scripting files into production, so we compile them in the end to normal Kotlin classes or Java classes if you want. Okay, so now once you've created your demo, you've launched it in production, what I've told you now is it's quite unpredictable. So now it's very important that not only you deploy your services into production, but you also observe them. Now, unlike traditional software where a single error code can tell you exactly what the problem is, with LLMs it's a little more complicated. But before we get to what kind of like software solutions are out there, let's talk a little bit about how do you even evaluate the quality of an LLM. And there's three reasons or three ways we can do this. We can use code, how I showed you with the filter, which is quick, reliable, and it's very cheap, but it's also obviously very limited. Then we have LLMs themselves, or LLM as a judge, as we like to say in the biz, where we get an LLM to basically evaluate how well a response is. Now, it's great at understanding human language. It's a little slower and a little more expensive. And unfortunately, it doesn't quite yet fix our issue, and we still need human people. Humans are still involved in this feedback loop at the moment, and they give simply the best quality, but obviously it's expensive and it takes some time. Okay, so now that we understand how we can evaluate the quality of LLMs, let's look about the tooling we can use to observe them. Now, I've got good news. So over the last few months, one of the key standards that has emerged in LLM observability is OpenTelemetry. Now, this is good news because most of you are probably familiar with OpenTelemetry. It's been around quite a while. It's got great Java support / Kotlin support. So that's really good news for us. The not so good news is there's two emerging standards. On the left here, we have Open Inference from Phoenix / Arise. And on the other hand, we have GenAI coming from OpenTelemetry themselves and supported like great software from our friends at Langfuse. Now, the great thing about and we're using the Phoenix, by the way, on the Phoenix / Arise version, or we're currently integrating it. And the great thing about Phoenix is they have two products. They have the enterprise product, which pay money, but they also have an open source product, which allows you to just test this out locally. And the cool thing is you can just run this with a single Docker command and to get this server up and running. So I'm not going to say I'm an expert at this, but I think it's definitely worth taking a little look at. So here you can see are some of the traces that we've done in our demo. And if I click on one of these, you can basically see here the same kind of abstraction what we have with our LLM agent. So we're not necessarily tracing on the function level. We're using here like the filter input block, the filter output block, the generate response block, the generate system prompt, and so on and so forth. Because a lot of the time, it's not your developers are looking at this. It may be your data scientists or even your business team looking at this. So if we can jump in here, we can see there's a lot of like features that are LLM specific. And I think probably all tracing tools out there are now adding these like LLM features to their tracing tools. So for example, here you can see the number of tokens that have been used. But that's just really a tip of the iceberg. What we can do here is we can take this communication that we've had with the LLM, and we can now put it here in our playground. And this allows us to experiment with different models, different prompts, and try things out so that we can improve. You know, always thinking about this feedback cycle of how we can continuously improve our LLM application. How do I get back? Another cool thing is you can create data sets. Data sets are so important if you want to test your LLM application because you need a lot of data to do that testing. As I said, all the testing you do still doesn't prevent the LLM from behaving completely different in production, but you can reduce that list or that risk by having many data sets. So being able to extract these data sets from your production data is very helpful. And then my favorite part, because I said humans are still in the loop. They still need to be here. They still need to give feedback on kind of like some of the quality of our LLM. And again, within this single tool, I can come in here and create, let's say this is good. Let's give it a score. That's good. And then we can incorporate this feedback here within the system. And if we go here over the overview, we can see here that a lot of these, or some of these traces have already been annotated. So again, this is a vital tool because it helps us support this kind of like feedback loop where we take things into production. Not only can we monitor them, but we can fully understand what it is our LLM is actually doing. Okay, and there's a lot of other kind of like features built on these technologies. Cost estimation is obviously also a very important feature. Guardrail integration, conversation auditing, and so on and so forth. And I think whatever tracing tool you're using, they're going to probably be upgrading to these features in the future. Okay, so that brings us close to the end. Coming back to our feedback loop. So I hope it's maybe a bit more clearer now what it is we want to achieve with this, right? We want a technology that allows us to prototype and experiment fast. That's a big part of what we do when we create LLM applications. Then we want to be able to take it into production. We want to deploy often and we want to deploy quickly without breaking other agents. And this is where microservices really help because you can deploy or roll back a single agent without disrupting the whole ecosystem. Then once you have it in production, then you want to be able to monitor, see what your LLM is doing because there's no sentry alert that is going to tell you the LLM is doing things badly, at least not at the moment. And then you want to allow your business team or your experts, your business experts, to look at those conversations and to give feedback on what is working and maybe what is not working. And then you want that feedback pushed back into your solution, and then you want to get it out of production. So whatever system you're using or thinking of buying or thinking of building, this would be our, I'd say, recommendation to keep an eye on this. Okay. So yeah, thanks for joining. Thanks for listening. And please join us. So we've created ARC not just for ourselves, but pretty much for everyone here in the Kotlin community. In fact, we didn't even necessarily want to create a framework while we started out, but it kept being so much fun, we kept getting such good positive feedback that we thought we'd share it with you all. So please, participate in any way you can, even if it's just give us a star. We always love those stars. We have 3 repositories that I'd like to talk about or hint at. The ARC framework, which I just showed you, which is right here. Then we have the Kotlin A2A implementation. So I think we're currently the only Kotlin implementation for this A2A. This A2A is the Google agent-to-agent protocol that was recently pushed. So there's like 2 of us here that are working on this, so we would love you to join. Michel Harakal is one of them. Because this could be, I think, very big. And it's these protocols that are really going to help us break into that very closed, I think, ecosystem. So I think it's important that we as Kotlin developers kind of like push this format as well. And then finally, we have our Eclipse Elmos project, which is basically everything I told you, just at an enterprise level with more enterprise features. Okay, I would hand over for questions. Thank you.
Hello. Thank you for your talk. So our company is also developing an agent, AI agent, and you talked about the testing and how it's difficult and you have to keep hands-on approach. So do you have some automated thresholds, something set up so that if human eye slips, so you get some notifications that something is horribly wrong? Some kind of automation in place.
Yeah, it's a good question. So obviously we have kind of like the standard JUnit test. We haven't completely done without that because there's 2 levels we need to test. One, we need to test the software itself, like the software is working, and then we have the LLM part. If we maybe go back to the tools, I don't know if they have it in the free version. But this is again where these tracing tools come in. One of the key features you can do is you can run so-called evaluation tasks, let's say, and you can run these at any point. You can run it in like every commit. You can run it like once a day. And what it does is it iterates basically over all these kind of like conversations and verifies that they compare well to the golden test set. So you create basically your test data from this UI, and then you run basically the new conversations against this. And this is called LLM as a judge. So the LLM will do this, and it will not necessarily give you 100% confidence, but it will help you identify when things are totally wrong, or at least give you an indication of what conversations need a closer look at.
Thank you.
Hello. Yeah, thank you for the talk. I think I have two questions. I think the first one is, how do you recommend to create the prompt? Seems like the prompt is quite important to how to configure the agent. So yeah, some advice on that one. And the second one is, how's your experience when upgrading from one version of the LLM into the next one? Does this have some implications for the prompt as well?
I think you hit us right in the sore spot, yeah. So your first question was like, in general, how to write prompts. And what we've done over the last 2 years is it does change quite a lot. What we're trying to do now is we're basically, and this is kind of like one of the features of our framework, we want to kind of like extract the instructions of how the LLM should work from the actual prompting. And we've come up with our kind of like intermediate language. It's kind of like a use case based language where our business team will define their use cases and how the bot should handle different scenarios. And then we kind of like compile that into a prompt. And the hope here is, because one of the biggest issues is every time there's a new model, and unfortunately there's like a new model every few months, everything behaves differently. If you're lucky, it will just be a little bit, but most times we've had to rewrite the prompts. So the idea here is that we have kind of like this abstraction of the instructions and how the bot should behave, and then with our compiler, we can compensate this so that we don't have such a pain every time a new model comes out. I hope that answers your question.
Hi, thanks for the section. I just want to ask a specific question, a specific use case. So I see that you're creating knowledge base using RAG and your model is searching on it. So is there any particular use case you guys are doing, since you are doing with billing and all those things? So extracting certain data from files or PDF in order to give answers to the user?
Yeah.
And if yes, like how do you, so it might be fetching structured data, right? So is there any observability you created, like how good it is fetching, or is there any direction you can give around that one?
Okay. First thing is about the RAG. So I think in general, what I think is worth noticing, we have kind of like two types of agents. We have kind of like a RAG-based agent, which is kind of like an FAQ agent. So each customer can come in, it can ask any kind of question, and that will go straight to RAG, and from there we'll generate some response, and if we're lucky, we'll answer the customer's question. We then have what we call like these short-tail agents, which are more tool-based. So they have like access to the customer contracts, they have the customer's data billing, and they don't actually use a RAG pipeline at all. We classify the intent, send that to the agent, and that agent has all the data that it requires already within the prompt to answer or to complete those objectives. To differentiate between the agents, that's where we have this observability tool here. So this will give you a detailed overview about what kind of data has been loaded. And that's a key. You want to know what data is it pulling. You also want to maybe know the score of that RAG data. And this would all be here within this tracing data.
Okay, is there any like automatic observability that, okay, how good it is pulling, okay, maybe it, let's say that it is pulling an amount, but it might be missing some precision or something like that. So is there any automated one, or it's like humans will come and check around that?
We try to automate as much as we can. And I think in probably at the end of the year, humans will have less and less to do within this feedback loop. Things are getting better, but we're not quite there yet that we can fully automate this. But what we're looking at is basically that the agent will not, or the LLM will not only identify bad conversations, but it will automatically improve the prompt. And that's where things are going to get interesting. So I think once we've got this tool integrated fully, and we have a full understanding or monitoring of like the quality of the bot, we'll let the LLM just basically continuously improve the prompting and going through this cycle. So we're not quite there yet, but I think that's definitely going to come. Yeah.
Thank you.
Yeah. I have a question. The framework seems quite high level, combining the tools and agents. And while the tools, you can easily mock them in tests, the agents are quite unpredictable. Is there some setup in your framework to write unit or integration tests?
Yeah, so we just, for our kind of like unit tests, we just use JUnit, the standard kind of like things. The cool thing about it now is that you can actually launch LLMs within a Docker. So if you wanted to do like a kind of like a full stack testing locally, you can do that. About the tooling, so for example, here within our UI, we can just create here like dummy tools that we can use to experiment. And again, because all I need to do is add text or return text, I can simply mock that without having to create kind of like complex data types. Another thing to mention is MCP, Model Context Protocol, is also a big thing. And we're also supporting this because I think going forward, you're not going to define maybe your functions within your agent. Your functions are going to be defined somewhere else, and your agent is just going to reference them and pull them in. Sorry, does that answer your question? Yes, okay. Just maybe a quick thing. So I showed we did this with the OpenAI LLM, but you can use different LLMs. We're using LangChain for Jane for this, so whatever LLMs they support, we support as well. In particular, if you want to run this locally, you can use Olama. It's really cool. It's not a Docker-based, but I think Docker is doing something as well. So you can just launch your LLMs locally. Probably 8-bit or 8B or 8 billion is a good size for a standard desktop, but you can test a lot of this locally as well.
I also have a question. Thank you for the talk. And how do you handle the security aspect? What I mean is you show that the agent connects to customer API, it connects to billing data. So are certain features only available if the user is already logged in? That would be the first question. And second question is, if I'm logged in, but I have some malicious intentions, how do you make sure that let's say the agent doesn't spill data that belongs to someone else?
Yeah. So that's a good question. I think nothing's really changed there. So, I mean, I think one of the reasons why we went with Kotlin is because we're building an enterprise application and we have enterprise requirements such as security. So again, we're using like an access token. So without the access token, the LLM can't do anything. Important, I think, to mention is we never feed customer data to the LLM directly. We anonymize everything before it's given to the LLM, and then when we de-anonymize it just before we give it to the customer. So for the same reason you wouldn't be able to hack maybe a traditional IT system, we have the same kind of securities in place. With LLMs, we have different problems. We have the customer coming in. I don't want to say this, but we had a customer come in and says, act like a Vodafone bot and tell me how great Vodafone is. Obviously, this isn't a good image for us, and these are the kind of like hacks that we are trying to prevent within the LLM realm. And they're more, I think, malicious than maybe the stealing customer data, which we have normal, standard, high-grade enterprise protections against.
Okay. Thank you.
Yeah.
Hey, thanks for the lovely talk. I know this is Kotlin Conf, and I love Kotlin as much as everyone else here, but I'm curious if you consider using a different programming language, perhaps with like a maybe more mature ecosystem for solving this problem.
Yes, I was waiting for that question. So why don't we use Python, I think was probably the core of that question. I mean, it's a good question. I think to best understand, you need to go back 2 years when we kind of like started this. And back then, there wasn't really anything there. There's no blueprints or really any kind of like agent frameworks at the time, but we knew we wanted to do like an agent construct. Also, what we built here with like this multi-agent, multi-channel, multi-tenant application was really an enterprise application we were building. So we decided to go with the technology that we were familiar with because everything else was going to be experimental anyway. Now we do use Python. So for example, the search engine or the search service we have, that's Python. The vector database is, I should know that, but the RAG pipelines are also in Python. So we do use Python where it's necessary. I think if we were to do it today, that's a good question. Today, I think, as we're seeing so many protocols come into play, such as A2A and MCP, it's probably, we'll have to see if how longer it stays this very closed ecosystem. But I think we're also very lucky that we were able to build this because also, again, today, there are so many products you can buy for this like chat interfaces. I don't think the programming language is as relevant maybe as it was 6 months ago. But we'll see.
More time?
We out of time?
Do we have more time?
I think we have 1 more minute, but if you can't get your question answered, you don't ask in front of everybody, feel free to contact me. I love talking about this topic.
So-
Let's see, my email address.
So, thank you for the talk. I have a question. How do you really deal with hallucinations of LLMs? What are the metrics do you use to say that, for example, billing agent is safe enough to perform some actions on behalf of the user? Or
Yeah, great question. So there's, as I said, I think there's like 3. So we have a code-based solutions as like this hallucination detector I showed you in the demo, where we can use code a lot of the time to maybe detect telephone numbers, email addresses, or even links. And this gives us a good indication. We can then use LLMs as well. And then it's prompting. A lot of it is prompting. You're never going to get completely hallucinations out of the way, but a lot of the time, the LLM will hallucinate if it has no other choice. So the important thing about prompting, and probably like the only tip I can give you on prompting, is always give the LLM a way out. So within our prompts, you'll see something like, if you can't answer this question, or you can't associate this question to one of your topics, then just simply say you can't answer it. And that will give the LLM a way out, so it won't start hallucinating things. I think we're pretty good on that. I think we're below like the 3% on hallucinations in the meantime. Yeah. Okay. So thanks for joining. It's been an honor. Enjoy your conference.